So a reminder about our notation. If I am differentiating, I am finding the gradient, which we're used to calling m. So the derivative is the same as m, the gradient. We're also using some other notation now, which is y dash. That also means the derivative. dy over dx or f dash x. All of those things mean the gradient or the derivative. So using the short method to differentiate, we do one term of our equation at a time. And what you do is you bring the power down to the front. So if the power is n, you see that little equation in there? If the power is the n, you bring it down to the front of the term and it multiplies. If there was another number there, it would multiply with the number that was there. So the n is going to multiply with the k down at the front. Then for the x itself, you will subtract 1 off the power. So that's why there's a little n minus 1. Okay. That is more of a process rather than a formula that you want to substitute into. So let's see it in practice. Here is example number 1. If I want to differentiate the following, I'm differentiating y, so I'm going to call this a y dash for my derivative. The process is the power of 5 there, bring the power down to the front, leave the x, and subtract 1 from its power. Done. I have differentiated that function or that curve. That's the gradient of that equation. Okay, let's try it again. Part B. It's y again, just for fun. I could call it y dash, but there are other ways, remember? So just for fun, I'm going to call it dy dx. Means the same thing, derivative of y with respect to x, just to make sure that you can use all the different types of notation. So the process is the power, you bring it down to the front and you times it with the number that's already there. So 4 times 3 is 12. The x stays there and you subtract 1 from the power, which is a 3. Okay, so that is the gradient of that one. You like the short method yet? Yeah. Good. All right, C. There's lots of terms in this one, so we have to do it for each one. So it's f of x, so it's going to be f dash x for the gradient. The first term, bring the 6 down the front and times it with the 2. 6 times 2 is 12. Leave the x and subtract 1 from the power, which is 5. Now move on to the next term. It's a x to the power of 4. So the 4 is going to come down the front. 4x, subtract 1 from the power, is a 3. The next one, minus 3x squared. So the 2 is going to come down and times with the minus 3, which is negative 6. Leave the x and subtract 1 from the power would be a power of 1. Don't have to write it if it's a 1 though. The 5x. The power would be a 1. The process does still work. The 1 would come down, which is 1 times 5 is 5. And then it would be x. Subtract 1 from the power would be 0. So what you'll find, instead of writing x to the power of 0, x to the power of 0 is just 1. We don't actually need any x's there at all. So when you're differentiating a term that is just an x term, the x will disappear altogether and it will just be the number in front of it. And the 2, the constant on the end, there is no x there at all. That term will disappear completely. All right, let's do it again. Part D. I want to differentiate y equals brackets 2x plus 1 all squared. Okay, at the moment, we can't do it if we have brackets in there. I'm going to teach you some techniques later that you will be able to, not yet, okay? So for now, we need to expand those brackets out. So using our short method, 2x times 2x is 4x squared. Timesing the middle terms together and doubling, 1 times 2x is 2x, doubled is 4x. And then the last term times by itself, 1 times 1 is 1. Now notice that I'm still calling that y equals. That is not a derivative. I had just expanded. Now on my next line, I'm going to call that y dash, or you could use dy dx. Both are the same. And I'm going to differentiate. So first term, I bring the 2 down the front. 2 times 4 is 8. X, and subtract 1 from the power would be a 1. The 4x term, the 4 is going to stay and the x is going to disappear, and the 1, the constant term, will disappear. That's it. Question 2. If f of x equals x cubed plus 2x squared minus 4x plus 1, find f dash 2. Very similar to what I was doing over here, but we're using the short method to differentiate instead of all of that. Okay, so differentiate first. Always differentiate first before subbing anything in. So f dash x. To differentiate first term, bring the 3 down the front. Leave the x, subtract 1 from the power. So 3x squared. Second term, bring the 2 down and times it with the 2 that's already there. So that's 4x to the 1, or just 4x. Then the minus 4x, because it's just an x to the power of 1 or an x term, it'll be minus 4 and the x will disappear and the 1 will also disappear. Once we have the derivative equation, if I want to find out what f dash 2 is, I can then substitute 2 everywhere where there is an x. So it's like saying I specifically want to know the gradient where x is equal to 2. So I'm going to be subbing that in. So it's 3 times 2 squared plus 4 times 2 minus 4. What was it? I thought someone said the answer. 16. Excellent. Okay. That's how you do the short method. On the next page, these questions want us to use our short method of differentiating, but we actually want to go a step further. We want to use our gradients to help us do some other things. Okay? Combine it with some of the other skills that you learned at the beginning of the year and hopefully haven't forgotten. So question 3, consider f of x equals x plus 3 all squared. So first of all, it says find the equation and the angle of inclination. So there's 2 things I have to find at the point of the tangent, at the point a equals 0, 9. Now this sounds a little bit like our straight line graph stuff that we had to do, with parallel lines and perpendicular line, finding the equations of things, and we're going to be using many of those formulas in here. The only difference is that I'm finding the gradients of curves now instead of lines. And if I have to find a gradient of a curve, then I have to differentiate it. Okay? So my equation is f of x equals, I don't like having the brackets in there, so I have to expand that out. So that's going to be x times x is x squared, x times 3 is 3x, and I double to get 6x, and 3 times 3 is 9. To find the gradient, I have to differentiate. So f dash x equals, the 2 comes down the front, so it will be 2x for the first term. Second term will be the 6, and the x will disappear, and the constant term will disappear. So there's my gradient function, we call that. I am trying to find an equation of a tangent at the point x equals 0, y equals 9. Now the 9 part doesn't help me much right now. It's the x value that's important here, that x is equal to 0. I want to sub in when x is equal to 0, or in other words, f dash of 0. Okay, so that's going to be 2 times 0 plus 6. 2 times 0 is just 0, so that's just equal to 6. Now remember, it looks a little bit funny in there, f dash 0, but that really is just a gradient. I have now found the gradient of that tangent, and if you prefer, you don't have to write the m there, but it does mean that's m, the gradient that we use in a lot of our other formulas. Okay, so if I want to find the equation of that tangent, I have a point. This is the point, so now the 9 is going to be useful because I need the y value for that. And I have a gradient, correct, so point gradient formula. So just in case you've forgotten, I'm sure no one's forgotten, y minus y1 equals m, x minus x1. Point gradient formula. So x1, y1 from my point A up here and my gradient of 6. Let's sub them in. Y take away 9 equals m is 6, bracket, x take away x1, which is 0. Now x take away 0, that's just x. I've really just got y minus 9 equals 6x. And then I could add the 9 across the other side. So y equals 6x plus 9. Okay, so that's one of the things that I was asked for. That's the equation of my tangent. But remember, there was a second one. It also asked for the angle of inclination. Do you remember the formula for angles of inclination? Yeah. M equals tan theta. Remember, m equals tan theta from trigonometry. Look at it all coming together now. So if I want to find the angle of inclination, all I have to do is put my m, which is 6, into that formula. So 6 equals tan theta. To find the theta, I will inverse tan that. And I'm just going to round to the nearest degree. Pretty sure you'll get 81 degrees if you inverse tan 6. Okay, so that's my second part. Angle of inclination is 81 degrees, and we have our equation of our tangent there. Okay, see how useful gradients are. All right, let's keep going. Part B. This is all there's quite a few parts to this question we're going to do. Find the gradient and the angle of inclination of the normal at A and draw a sketch. Maybe we should start with the sketch so we can see what we're doing here. So far, I'm going to do it over here on the right. I started with a parabola. The equation of my parabola was x plus 3 in brackets all squared. We learnt that, what first topic? I've moved my vertex of my parabola across to -3. The y-intercept would be from here, it would be that 3 squared, which would be 9. Or in other words, if you want the expanded version, see the expanded version of my parabola here? The 9 on the end, that's going to be my y-intercept. Okay, so it's pretty rough, but my parabola looks like that. We have found a tangent. So let me see if I can get my ruler out here. We have found a tangent, and we found the equation of it. It's coming down here like that. There's my tangent. I found the equation, and it kind of looks like an 81 degree angle of inclination there. Yeah, it's in the ballpark. Okay, that's what I've found, that equation and that angle of that line. But now I want to find the normal, which means I have to make a perpendicular line. Normal means perpendicular to that red one that I've drawn there. And I have another line coming down here like this. Okay, so that should be a right angle in there. And that's the line that we're talking about now, that normal. So I want to find its gradient and I want to find its angle of inclination. We already know from part A that the gradient of the tangent was 6. So the gradient of the normal, if that's going to be my m1, the m2 is the normal, which is -1 over 6. Is everyone okay with the negative reciprocal? Hopefully. Okay, there's my gradient. The angle of inclination is going to be using the m equals tan theta again, but using that new gradient that I've just found. So the -1 over 6 equals tan theta. And then I would inverse tan that and get, calculator says, -9 degrees. Why would it be saying -9 degrees? Because the angle that would be making with the x-axis is actually an obtuse angle. So it goes, nah, I want to tell the acute angle, and it will tell you the one going down from the x-axis instead. If we want to force that to be an obtuse angle, what do I need to do? 180 minus the 9. So 180 minus 9 is going to be an angle of, I'll write it down here, 180 minus 9. So that's going to be equal to 171 degrees for the obtuse angle. Let me extend my graph out here so you can see what I mean. When these connect up out here, that's going to be 171 degrees way out there. Okay, and this red one here was my 81 degrees in there.
It's minus 9, so wouldn't it be minus 9?
The minus 9, no, you don't want to double minus it. The 9 is that angle there. So it's 9 degrees going down here. Just telling you the reason it's negative is because it's below, but it's still a straight line with a 9 degree angle. So it's only 180 minus 9. Okay? All right, that is all we need to do for part B. We've found the gradient, we've found the angle of inclination. Part C, find the x-intercepts of the tangent and normal by finding their equation. And the normal by finding their equation. I already know the equation of the tangent, so I can find the x-intercepts of that. So let's start with the tangent. So write small in here, there's going to be a little bit of working out. So the tangent, we found the equation, which was y equals 6x plus 9. To find the x-intercept, I sub in when y equals 0. So I put 0 equals 6x plus 9 and solve for x. 6x equals minus 9. X is equal to minus 9 over 6, which simplifies to minus 3 over 2. Okay, so that is, I'm going to find a different color that I can use in here. How about orange? That number in there would be minus 3 over 2, where my tangent is tangent is hitting the x-axis there. I kind of already know it, but what's my y-intercept there? 9. It's already on the graph. You can see the y-intercept of that line is already on there. Okay, let's go to the normal. I don't know the equation of my normal yet, so I have to find it. I do know that the gradient is negative 1/6, and I also know that it is going through the same point as my tangent, which was the point 0,9. So point gradient formula again, which will be y take away 9 equals negative 1/6, x take away 0. When there is a fraction for a gradient, times the 6 across rather than having lots of fractions in your equation. However, it is okay if you leave it in y equals mx plus b form if you want to, but I'm going to get rid of the fraction. So that's 6y take away 9 6s are 54 equals minus x. And that way I can write my equation in general form, which would be positive x plus 6y minus 54 equals 0. The y-intercept is still 9 of the normal, right? But I want to find the x-intercept of that, which means I will now sub in when y equals 0. When y equals 0, I get x plus 6 times 0 minus 54 equals 0. 6 times 0 is nothing. So moving the 54 across to the other side, I get x is equal to 54. And that's why I had to extend that line out a ridiculously amount over here. That intercept there is at 54. Okay, one last part. D. Find the area of the triangle formed by the tangent and the normal and the x-axis. So the tangent, the normal, and the x-axis. I want this triangle. Easy peasy. Area of a triangle. Half the base times the height. Okay? And it's a right angle. It's not a right angle triangle, but I do have a perpendicular height. So area equals half base times height. That's our formula. The base of that triangle, which is how far? So it is the 54, 55 and a half. Excellent. So half times 55 and a half, or 55.5, times by the height of that triangle, which is 9. So its area is 249.75. We don't actually know if that's centimeters or what the units are, so if we write units squared.